Hello, Professor Rad here, and today we're going to talk about conditional probability formulas. So before we just list the formulas out, I wanted to start out with just one of the images that we used in the last video when we found conditional probabilities with a two-way table. So in this situation, we were given the condition of 2, this category of 2, and we were interested in the probability that somebody was a non-smoker in that category. So when we are finding these values, these two blue boxes represented, this was our numerator and this was the denominator. So notice that the numerator of this situation is where the two categories intersect. So this is where our given condition is intersecting with our probability. And earlier we saw that when two things intersected, they happened at the same time. That meant that we had an and probability. So this blue box here would be the numerator of finding the probability of NS and 2. The second blue box here is representing the total number of people who lived in this category 2. So we could think of this blue box as being like the numerator of the probability of just 2 happening out of everyone. So cooked up in here, we have an and probability and a total probability for our given column happening within this picture. So here's how that informs the formulas. The probability of x given y is going to be the and, so the probability of x and y, over that given condition. So here's that probability of y. Now, if you like this formula and you want to use it, feel free to do so. But I always have a problem remembering the order of things. So I always had a problem remembering who went in the denominator. Was it x or y? So more helpful for me personally was thinking of it in terms of words. So the probability of an event given a given condition is the probability of the event and the given over the probability of the given. So it helped me to remember that the given or the second one is what ends up being in the denominator. Also, remember that an and probability doesn't mean like take the probability of the event, the probability of the given, and add them up. It doesn't mean that. An and probability is its own like single value, single number. Now, if I take this formula here, I can rearrange it by multiplying both sides by the probability of y, and that's a way that I can solve for the probability of x and y. That's what's given here in this format here. So these two equations are actually the same thing. They've just been rearranged to, depending on whether I'm looking for a conditional probability or whether I'm looking for an and probability. So the formula we had for x and y in the past was an addition formula. We had the probability of x plus the probability of y minus the probability of x or y. This is a new formula for the probability of x and y that we can use if we have different information provided to us. So sometimes you might have seen this before where you multiply two things to get an and probability. Those two things you would be multiplying are a probability and a conditional. So let's go ahead and see these in work in an example. So in this example, let me keep my formulas here for reference. We know that the probability of A is 32/100ths, the probability of B is 1/2, the probability of C is 0.92, the probability of A and B is 0.16, and we have a conditional probability. If I know that B has happened, the probability of C is 0.96. So for part A, they want us to find the probability of A given B. So I'm going to go ahead and use this format of the formula. So in this case, A is the event and B is the given. So this is going to be the probability of A and B, the event and the given, over the probability of the given, which in this case is B, since that's the second one provided. This is where I was mentioning before that the probability of A and B is going to be a probability that's given to us, okay? So it's going to be one number provided. So this is 0.16. and then the probability of B goes in the denominator. So the probability of B was 0.50. When I divide that out, I end up getting 0.32. Exactly, I didn't even have to round. All right, so let's go ahead and do this next one. So for part B, it says the probability of B and C. Now, in order to know which and formula I should use for this problem, I need to look at the information that I have. So I have the probability of B, I have the probability of C. This one I don't care about because I don't care about A for this problem. And then I have a conditional probability, the probability of C given B. So because I know this, instead of knowing the probability of B or C, that's what tells me I'm going to use this formula. Okay, so this is like this is like the lock, I guess, or the key, and then this is its corresponding piece. So I'm gonna go ahead and use B instead of X, and or sorry, I'm gonna use C instead of X for this one, and B instead of Y, because here I know C given B, so I know C given B. Okay, so that's how I'm going to do this replacement. So we have the probability of C given B times the probability of B. Notice that the given condition is the same as the one that I end up multiplying by. So the probability of C was 0.90, or sorry, the probability of C given B was 0.96, and the probability of B was 0.5. And that gives me 0.48. So that would be my answer for part B. Now, parts C and D are review questions for this problem. So if you want to pause the video here and work through these two parts, feel free to do so. And then when you are done, you can unpause and I'll walk through them together, and you can check to see if your work is correct. All right, so let's walk through part C. Now, one of the things that's tricky about this one is that remember that this thing that kind of looks like an exponent has absolutely nothing to do with the event called C. This little c here that looks like an exponent means complement, and our formula for complement is 1 minus the probability of the event itself. So to find the probability of the complement of A, I'm going to do 1 minus 0.32. And that's going to give me 0.68. For part D, we have the probability of A or B, and we only have one formula for or. So this will be the probability of A plus the probability of B minus the probability of A and B. So the probability of A was 0.32, the probability of B was 0.50, and the probability of A and B was given to us as 0.16. So when we work that out, we end up getting 0.66. All right, so there we go. Hopefully you did all right with parts C and D. Before we conclude, there are a couple things that I want to mention about some common mistakes that are made on these problems. So in part A, when we're finding a conditional probability, let me I'll write it out in maybe a different color here. So some common mistakes or things to watch out for. One of the common mistakes I often see is instead of using a conditional probability formula, is just doing misspelling mistakes. That's funny. But is just doing this because this kind of looks like A over B. So a lot of times when we're first learning this, we want to do this. So this is wrong. You can't do that. You need the and probability. The other mistake that's on here is I'll often see something like this. So instead of using an and, I'll often see A and B being added together and then dividing that by B. And what ends up happening is if you do this, you're always going to get something that's bigger than 1 because the probability of B plus the probability of A is going to be bigger than the probability of B because you're adding B plus A. So you're going to get something bigger than B. So you'll get something larger than 1, which you should know right away is wrong because probabilities cannot be bigger than 1. You can sometimes get a probability bigger than 1 if you use this formula, depending on how A and B are related. So just be careful, make sure you don't make mistakes like these. With part C, this is one that I often see a mistake on, and let me show you what the mistake that I often see here. So mistake. And I'm going to use this specific example as an example. So maybe something like, so this is a situation where I'm also getting an answer that's bigger than 1. So I know I've got a mistake. So let's talk about where I got 0.50 and 0.92 from and why I might use them. So 0.50 was the probability of B and 0.92 was the probability of C. So the reason I think sometimes we want to do this is because we think certain events are mutually exclusive when they are not. So in this situation, we can see that A and B can happen at the same time. So B is not the opposite of A because they can happen at the same time. So just because A isn't happening doesn't mean that B has to. Doesn't mean that C has to either. We don't know what these events are, but A not happening doesn't mean that B or C or either one has to occur. So a common mistake is to add these up as if we were dealing with mutually exclusive events. That's also a mistake for part D. So in part D, a common mistake is leaving off the subtraction piece. So you want to make sure that you don't do that, that when you're finding an or probability, you want to make sure that you're subtracting that and piece, especially if it's been given to us. So that's where we're going to wrap up this video. In the next video, we're going to talk about independent events, which is similar to mutually exclusive in a kind of a way, but it's also totally different. So I'm looking forward to seeing you then and talking about what I just meant by that. And yeah, I hope you have a fantastic day. Bye for now, everybody.